teacher guide is about our Mindset Learn series of lessons called Introduction to Electronics. In this guide, we tell you what the series of lessons is about and how it links to the curriculum. We also discuss ideas for using the lessons with your learners. You may want to make notes, so have pencil and paper ready. There are 4 lessons in this series in which we show how different materials are affected by electricity. We do this by investigating the relationship between potential difference and current for conductors, insulators, and semiconductors. We also show how these materials are used to make different electronic components, including resistors, capacitors, diodes, and LEDs. This series of lessons links to the core knowledge areas of matter and materials and electricity and magnetism, and addresses concepts required in the themes of electronic properties of matter, electrostatics, and electric circuits. In this series, we have conducted experiments in order to support an inquiry approach and to assist learners in the construction of the required concepts. In this way, we have addressed the assessment standards related to learning outcomes 1 and 2. We also show how electronic devices are used all around us. This clearly shows how science and technology has impacted society, and so will give you opportunities to address some of the assessment standards of learning outcome 3. The learning outcome and assessment standards for each lesson are stated at the beginning of each video lesson in the series. In addition, lesson outcomes linked to these are also given for each lesson. The focus of this series is on Ohm's law. We begin by reviewing Ohm's law and carry out an experiment using different metal conductors. Once we have established the relationship between potential difference and current for conductors, we use energy band theory to explain our macroscopic observations. We apply the same experimental procedure to insulators and use energy band theory to explain why insulators do not allow charge to move. We then show how insulators fulfill an important function in capacitors. In the last 2 lessons, we focus on semiconductors and show that silicon behaves as an insulator at low temperature and as a conductor at high temperature. We examine how silicon is doped to make N and P-type semiconductors and explore what happens at a P-N junction. We show how the P-N junction allows a diode to control the direction of current and see how light-emitting diodes work. The success of these video lessons depends on the way you use them in your classroom. We suggest that you watch the lessons yourself as part of your planning. Decide which videos you will use and think about how to integrate them into your learning program. To get the full benefit of the lessons, your learners need to engage actively with the concepts presented. So, when you preview the videos, think about how to introduce each lesson and what follow-up activities will be useful. Also, watch out for places in the video where you could pause to have a class discussion or ask learners to complete an activity or solve a problem posed in the video. We have used this pause icon to suggest some of these places to you. As you watch each lesson, make a note of materials and other resources you might need to bring to the class. For example, you could get your learners to test different electronic components such as resistors, capacitors, and diodes in a simple circuit. Assessment is an important part of teaching and learning, and the lessons provide opportunities for a range of different types of assessment. When you pause the video for learners to do an activity, you can assess their understanding of key ideas in the video and adjust your lesson plan if necessary. The task provided at the end of each lesson is always linked to at least one of the lesson outcomes, and thus provides you with a useful assessment opportunity. In the first lesson of this series, we review Ohm's law and show that identical pieces of copper and nichrome wire each have a constant resistance, but their resistance is not the same. This means that we can use combinations of materials to make a resistor with a particular value. These can be used in electronic circuits to control the size of the current passing through the circuit. But not all conductors obey Ohm's law. Light bulbs are non-ohmic conductors. In the task for this lesson, learners are asked to analyze potential difference and current readings collected when a light bulb is used in an Ohm's law experiment in place of a resistor. In lesson 2, we investigate how an insulator responds when potential difference is applied across its ends, and show what happens when a very large potential difference is applied between 2 points in air using a Van der Graaf generator. You can see how air, which is usually an insulator, undergoes electrical breakdown. Even though insulators do not allow charge to move, they are still very useful materials and are used to separate the plates of capacitors. In lesson 3, we investigate how semiconductors respond to electricity by applying a potential difference across the ends of some silicon wire at different temperatures. We also show how silicon can be doped to make either an N or P-type semiconductor. In our final lesson, we examine how N and P-type materials can combine to form a P-N junction, and show how charge can only move through this sort of junction when the P end is connected to the positive terminal of a battery and the N end is connected to the negative terminal. We find P-N junctions in diodes and LEDs. LEDs are special types of diodes that emit light that are being used in many different devices. In the task for this lesson, we ask learners to compare LEDs and light bulbs in order to evaluate how these electronic components may play a role as a light source in the future. There's a set of lesson notes for this video series on our website. These notes give a summary of the key points of each lesson and the tasks and suggested task answers. More detailed teacher support for this series, including additional ideas for assessing your learners' progress toward the assessment standards, is also available on the website. We hope this teacher guide has given you a useful overview to the series and will help you to use the Mindset resources when introducing electronics to your learners. Goodbye.